Alright, today we are learning about lesson 7.3, special products of polynomials. So our essential question is, how do you multiply special polynomials? We're going to be using a mixture of the area model and the distributive model for this lesson. So depending upon which one you like more, you can use either, but just note my examples will include both. We're going to start with our x plus 4 squared. Remember, this exponent right here means that we need to split this up. So we really have x plus 4 times x plus 4. So I'm going to do the area model on this first one here. So I'm going to take my box, and along the side I'm going to do an x plus 4. And along the top, I'm going to do an x plus 4. In our top left, I have an x times x, which is x squared. In the top right, I have an x times 4, which is 4x. In the bottom left, I have a 4 times x, which is 4x. And in the bottom right, 4 times 4, which is 16. So when I rewrite this, we get x squared plus 4x plus 4x plus 16, because I'm just reading, starting with the top left, going to the bottom right. So now we ask ourselves, can we combine any like terms? Yes, we have x's right here. So we get x squared plus 4x is 8x plus 16. That is as good as it gets. For our next one, let's try some distributive property on this one. Again, we have our exponent that says squared, that little 2 there. So I need to rewrite this so that we have 3x plus 2y times the quantity 3x plus 2y. This time let's do some distributive method on this, all right? So we have 3x and 2y, and we have 3x and 2y. Remember, with distributive, we want to make sure everyone in the first parentheses meets everyone in the next parentheses. So I am going to multiply my 3x by 3x. Sometimes you'll hear the distributive method referred to as FOIL. We haven't talked about that, but that might be something maybe your parents or an older sibling has mentioned, is FOIL. FOIL stands for first, outside, inside, last. It's a mnemonic device to remember how to multiply a binomial by a binomial. 3x and 3x are both first. So that's what we did. We did the first ones. And then it says outside. So I do a plus. The outside would be the 3x and this green 2y. They are on the outside. So we have 3x times 2y. The I stands for inside. So this is when we switch. 3x has met everyone in our next parentheses. So now we need 2y to meet everyone. So we have 2y times 3x. That's the inside, right? These two are on the inside. And then the last. So that means 2y is meeting the 2y. 2y times 2y. So that's what FOIL stands for. Again, we haven't talked about it. It's just a way to remember the distributive property. All right? It's a way to remember the distributive property specifically for a binomial times a binomial. So now that we have everyone meeting everyone else, and again, I like to color code these to make sure that I have everyone from the first meeting everyone from the second parentheses, we can actually multiply these. So 3x times 3x is 9x squared, plus 3x times 2y is 6xy, plus 2y times 3x is 6xy. Remember, write those alphabetically. X comes before y, plus 2y times 2y is 4y squared. Now I can look and say, hey, are there any like terms? Yeah, there are actually. We have an xy here, 6 of them, and we have 6xy here. So I can combine those like terms, and we have 9x squared plus 12xy plus 4y squared. I want you to remember because this is a little different, we know for standard form, we want to write it alphabetically first. But what if we have multiple variables? Because this 9x squared has a degree of 2. This xy has a degree of 2. And then this y squared also has a degree of 2. So the question is, which one comes first? They're all tied for degrees. So when we're writing standard form and we have terms that are tied for the same number of degrees, so we don't know which one comes first, we write them alphabetically. So we are going to start with the alphabetical variable first, the one that's all by itself. So in this case, which comes first, x or y? Well, x comes first, so we're going to write x first. This one only has x, and it's the highest degree, 2. So we're going to start with our 9x squared first. Then we will finish that variable, which in this case is x. The only other term that has x in it is our 12xy, so 12xy will come next. And we will end with the other variable. Another way to think about this is that x comes first alphabetically. We want to start with the most number of x's that we can, in this case the x squared, the highest degree x. Then we're going to do the next highest degree x, which is just 1x, or x to the first, I should say. And then we end with the lowest degree x. In this case, x to the 0. There is no x there. Try the next two. We've got negative m plus 3 squared, and then x plus 6 squared. All right, try the next two. Pause the video, try the next two. So for the next two, you should have gotten m squared minus 6m plus 9, and then x squared plus 12x plus 36. Again, you can use either method, area model or distributive property, whichever you prefer. We're going to turn over to page 2 next. All right, let's look at the second page. We're going to work on the problems on the left side together, so the right side will be for your own practice. So we're going to start up here with 6a minus 1 squared. Again, rewrite it, all right? It's always easier on the brain. 6a minus 1 times 6a minus 1, because that's what squared means. I'm going to use the distributive property for this one, because I feel like I'm on a roll with it. We've got 6a and our minus 1 here, and then we've got 6a and a minus 1. Everyone in the first parentheses meets everyone in the second. So I'm going to start with 6a times 6a, then plus 6a times, make sure this is a negative 1. Keep that subtraction side with the 1, turn it into a negative 1. Then I need to switch to my negative 1 times 6a. Sometimes it's easier to put that negative 1 in parentheses so you can make sure that you know it's a negative and not just an accidental mistake, because we all have typos sometimes. Then I need to do plus negative 1 times negative 1. Again, if you like parentheses more, that's great. If not, that's fine. Just be careful of your writing. Make sure it's easy to read. So when I do 6a times 6a, we get 36a squared. 6a times negative 1 is a minus 6a. Negative 1 times 6a is a negative 6a, or minus 6a. Negative 1 times negative 1 is a positive 1, so I am plus 1. Are there any like terms I can combine? Yes, I've got my a's in the middle here. So we have 36a squared minus 12a plus 1. And that is our final answer for that problem. I'm going to slide my paper up here a bit. So if you need to pause the video so you can still see that example, go for it. But I want to take a look at this bottom left one. The 3 minus x squared, and then that whole difference is being squared. So we again have an exponent here. Rewrite the problem. 3 minus x squared times 3 minus x squared. I'm going to do area model on this one because I've been doing a lot of distributive property. So for this one, I'm going to draw my box. I have 3 minus x squared. Remember, keep that subtraction sign and just turn it into a negative with the x. And then along the top here, I'm going to do 3 minus x squared. In my top left box, I have 3 times 3, which is 9. Then I have 3 times negative x squared, or negative 1 x squared. So this gets me a negative 3x squared. Then we have negative x squared times 3, which is a negative 3x squared. Then we have negative x squared times negative x squared. Be careful, negative times negative is a positive x. X squared, so we should have x2 plus 2, which is x to the 4th. So I'm just going to rewrite this, starting with my top left to my bottom right. 9 minus 3x squared minus 3x squared plus x to the 4th. Any like terms? Hopefully resoundingly you're all saying yes. We have 9 minus 6x squared plus x to the 4th. Is this written in standard form though? Is it written from the highest degree to the lowest degree? Well, the 9 has a degree of 0 because it's just a number. Minus 6x squared has a degree of 2 because that's our exponent is 2. And then x to the 4th has a degree of 4. So no, this is not in standard form. I need to rewrite this. The highest degree is x to the 4th, so he goes first. The next highest degree is our minus 6x squared, which means we are ending, like always, with our plain old number, in this case 9. That is my final answer in standard form. So try the right two, and we will go over them in just a minute. Pause the video, try the 2 questions on the right. So for the top right, you should have gotten 16c squared minus 24cd plus 9d squared. Remember, we start with the alphabetical variable first. In this case, c comes before d. We start with the highest degree c we have, then the next highest, and then work our way down. All right, so make sure your c comes first, and you end with your d squared. For our bottom right problem, the 7 minus x squared, you should have gotten x squared minus 14x plus 49. Please email me if you have questions. We're going to turn to the last page, page number 3. All right, on our page 3 here, we are going to look at the bottom 2 examples. I'm going to leave the top 2 for you to try on your own. So let's look at the bottom 2. For our first one, we have 3 plus 2y squared times 3 minus 2y squared. I'm going to stick with an area model for this one because I feel like I'm on a roll. So I'm drawing my box. And on the left here, I'm going to do 3 plus 2y squared. And along the top, I'm going to do a 3 minus 2y squared. Again, make sure that subtraction sign ends up as a negative with your 2. For our first box here, we have 3 times 3, so this is 9. For our second box, we have 3 times negative 2y squared. Well, 3 times negative 2 is negative 6, and we tack on our y squared. For our bottom left, we have 2y squared times 3. 2 times 3 is 6y squared. And then for our bottom right, we have 2y squared times negative 2y squared. Well, 2 times negative 2 is negative 4. Y squared times y squared is y to the 4th. Remember those power rules. That's why we spent almost a month on them. They are very important. So now, I'm going to rewrite this, starting with my top left. So 9 minus 6y squared plus 6y squared minus 4y to the 4th. Are there any like terms we can combine? Yes, there are. A minus 6y squared and a plus 6y squared. Well, minus 6 plus 6 gets us 0y squared. But wait a second, do I have anything there? 0 times anything is always 0. So really, I have 9 minus 4y to the 4th. Then we have to ask ourselves, is that form? 9 has a degree of 0. Negative 4y to the fourth has a degree of 4. No, it's not in standard form. So we need to rewrite this as negative 4y to the fourth. And remember, this is a plus 9, right? That's why I tell you guys to keep that subtraction sign and turn it into a negative, because this goes with the 4, not with the 9. So my final answer for this one is negative 4y to the fourth plus 9. For our next one, 9 plus r times the quantity 9 minus r. Let's do distributive method. So we have 9 times 9 plus 9 times negative r plus r times 9 plus r times negative r. Everyone in the first parentheses has met everyone in the second. 9 times 9 is 81. 9 times negative r is a negative 9r. R times 9 is a positive 9r. And then r times negative r is a negative r squared. Are there any like terms we can combine? Absolutely. We've got a negative 9r plus 9r, which is 0r. So we have 81 plus 0r minus r squared. Wait a second. If it's a 0r, do I even need to write this? No. So really this is 81 minus r squared. Now we have to check, is it in standard form? Do we have the highest degree first? Well, 81 has a degree of 0, and r squared has a degree of 2. So it's not in standard form. We need to rewrite this as negative r squared plus 81. Again, make sure that negative sign stays with the r, or make sure that minus sign stays with the r. And that is our final answer. So try the top two, pause the video, and we'll go over it in just a minute. So, our top left problem, you should have gotten x squared minus 36. And then our top right problem, you should have gotten x to the fourth minus 4y squared. Please email me if you have questions on this. You are never bugging me. I really enjoy hearing from you guys. So some of you may have noticed that these special products of polynomials have a little bit of a pattern. I want you to be able to multiply any polynomial by any polynomial, but I recognize that some of you might find this pattern to be really cool and interesting, and it really is cool and interesting. When you get into Algebra 2, you'll talk a lot more about these patterns and how you can find them in things like the Fibonacci sequence and even Pascal's triangle. So it's really cool and interesting. A little preview. If you're not interested in knowing the pattern, good, that's fine with me. Stop the video right now. There's no more new information. If you like patterns and you think math is fun and cool, then you'll want to keep viewing this. So if we have some polynomial, some binomial specifically, that is a plus b, whatever it is, a could be anything, it could be 2x, it could be 5y to the fifth, it could be anything, all right? So a and b just represent some term and some term. If we have a plus b squared, then the product will be a squared plus 2ab plus b squared. Every time that will happen. So you can take whatever the first one is and square it, whatever the last one is and square it, and then multiply a and b by 2, and that comes up with your middle term. If you have some term a minus b and you square it, you will get, every time, a squared minus 2ab plus b squared. So these are really similar, right? The only difference is that with our top one, we have a plus 2ab, and with our middle one here, we have a minus 2ab. And again, this will happen every time, no matter what your term for a and b are. So it's kind of a cool pattern. And then we have a plus b times a minus b. When you multiply these together, you end up with a squared minus b squared. So there is no middle term. And if you think about the last two example problems we did just before we turn to our very last page to write this down, you'll notice that for all of those, it was whatever the first term was squared minus whatever the second term was squared. So it's kind of cool, it's interesting. Again, these are just some patterns. You'll see them a lot more when you get into Algebra 2. What I care about is that I can give you this and you will be able to get whatever the answer is. All right, so you should be able to multiply any polynomial by any polynomial. I do not care that you have these special patterns memorized. I think they're cool and interesting, but I like math. The skills practice is posted to Big Ideas. Please take some time and work on it. There will be a quiz following this lesson. So you will want to make sure you're taking careful notes. And email me if you have any questions.